Okay, let's take a look at example 1, and let's just do part C from this example. And then after I do part C, you guys can have a go at doing part A and part B, just to make sure this whole idea makes a bit of sense. So if we do part C, that's going to give me 2 cos theta plus pi on 4 cos theta minus pi on 4. Now, if I have a quick scroll up and I have a look at my identities chart, well, I have cos A, cos B, so it's going to be this identity here. And let's just rewrite that part out. That's going to be cos A cos B is equal to a half cos A minus B plus cos A plus B. So there's my rule. And if I put things into the context of my rule, that means that this here is A, and this part on the end here is going to be B. So when I'm doing my angle subtraction, it's going to be theta plus pi on 4 minus theta minus pi on 4 is going to give me the angle I put here. And if I add the two, I'm going to get my angle I put over here on this side as well. Also, you notice I have a 2 at the front. So other things that are a little bit different. I have a 2 out the front here. So I have a 2 versus the half I have out the front on this side. That's a little hard to read. So I might get rid of that, but you can see we've got the 2. We have the half. So now if I put things into that context, I have 2 cos theta plus pi on 4 cos theta minus pi on 4. That is going to be equal to, it's going to be essentially a half times 2. So we're just going to leave that part alone. That's just going to be equal to cos of theta plus pi on 4 minus theta minus pi on 4 plus cos theta plus pi on 4 plus theta minus pi on 4. If I simplify my angles here, that means I'm going to have theta is going to cancel out. I'm going to have pi on 4 plus pi on 4. That is going to give cos of pi on 2 plus cos of 2 theta. Now, I know from my trig identities that cos of pi on 2 is actually equal to 0. So this is simply just going to equal cos of 2 theta. And that is all we really do when we're going from a product to a sum. In this case, my pi on 2 part's going to cancel out and give 0. So I wind up with this final solution. If we come down here to our second example, we have our sum to product identities rule. This part, unfortunately, is not on the formula sheet. There's a bit of a proof down here for kind of how this works. Basically, what we're doing is if I have sine 36 plus sine 10, let me just come back all the way up to my formula sheet. If I look at my addition 1 for cos. So where I'm adding two sine functions, it's over here. One way to think of it is I'm trying to figure out if I add two numbers and subtract two numbers, how do I get each of these numbers individually? And when we kind of consider how we can do that process, this rule here essentially comes about where instead of trying to think of what two numbers do I add and subtract to get my A and my B, if I make it A and B, I can add the two together and I can either subtract the two together or, add them depending on what my rule is based on my identity. So my first question is sine 36 plus sine 10. So if I'm in the exam, I'd go up, I'd look at my formula sheet. Once I'm looking at my formula sheet, I would then look at for where I'm adding my two sines. So if I come up here, I can see here's where I have sine plus sine or two sine functions being added together. And essentially what I have is I'm going to be swapping. I have A plus B. That's going to swap here for sine A. So it's going to become sine A plus B. And my cos part is going to become sine A minus B. Now I have my half out the front. To me, I kind of think of that as I need to times each of these angles by a half. That's sort of just one way you can think through how to get to this step here, where you can see if I have sine of A plus B, that's equal to 2 outside of A plus B divided by 2 cos A minus B divided by 2. Again, looking at the formula sheet, I have sine A minus B at the end, I have cos B at the end. So I just kind of am swapping my angles over and putting a divide by 2 division in there. And again, I multiply the whole thing through by 2 to get rid of the half. Hopefully that made a little bit of sense. It's a bit hard to kind of verbally explain, so I'm happy to go through that same idea with you guys in class as well. Let's just kind of go through and solve the problem. So if I have this, normally my rule is a half sine A plus B plus sine A minus B. So this time it's going to be 2 outside of sine. It's going to be 36 plus 10 divided by 2 cos 36 minus 10 divided by 2. If I go ahead and solve that, that's going to be 2 sine of, that's going to be 46 divided by 2, it's going to be sine of 23 degrees, cos of 13 degrees. A nice thing to note, if I did have exact values in here, then I could use exact values to simplify my answer, but in this case, I don't. So I'm going to leave my answer as such. The final question here for example 17 is to solve this equation here. So this is going to be sine of 3x plus sine of 11x. Now, just like before, this is going to become 2 sine, I add the two angles first. So this is going to be 3x plus 11x divided by 2 cosine, and I'm going to subtract my angles. In this case, I'm just finding the difference. So I'm always going to get a positive answer. I could do 3x minus 11, or I could do 11x minus 3x. Both are fine. You're going to find my answer is going to be the same as long as I take the positive solution. So if I go ahead and do this, 3x plus 11x is going to give me 14x. So that's going to become 2 sine 14x divided by 2 is going to give 7x. And this is going to give cos 11x minus 3x is going to give 8. So it's going to become cos of 4x. Now, I know from my question, this whole thing here is equal to 0. So now I'm just going to do some solving. That's going to result in 2 sine 7x cos 4x equals 0. To get 0, one of these two terms has to also give 0. So either sine 7x or cos 4x equals 0. So I can write that as being sine 7x equals 0 and cos of 4x equals 0. If I think of all the spots where sine x is 0, it's basically every pi. So that means that 7x is going to equal, well, sine 0 is 0. So it's going to be 0. It's going to be, it's going to be pi, 2 pi, 3 pi, 4 pi, oh wow, 5 pi, 6 pi. My domains up to pi, I have a 7 out the front here, which is kind of a nice hint, all the way up to 7 pi. If I do the same thing with cosine, that means 4x is going to equal, well, cos 0 is 1, so it's going to be pi on 2, 3 pi on 2, 5 pi on 2, and 7 pi on 2. Now, if I divide everything with my 7x by 7, that is going to give 0 still, pi on 7, 2 pi on 7, 3 pi on 7, 4 pi on 7, 5 pi on 7, 6 pi on 7, and pi. And if I do this side here, let's just change colors. That is going to give me pi on 8, 3 pi on 8, 5 pi on 8, and 7 pi on 8. So, wow, that's a lot of values. That's all my values for x I should write. This is what x could possibly equal to give 0 as a solution. So they're the two examples. Like I said, we have our formula sheet. So if we can understand our formula sheet, if we kind of get an idea of how to go the other way, we should find these problems aren't too challenging.